Alright, today we're covering UART. UART stands for Universal Asynchronous Receiver Transmitter. It's universal because it's used in a wide variety of digital components. You can see some examples that I have in the pictures here below. We have Bluetooth modules, Wi-Fi modules, SIM card modules, and GPS modules, and we have a lot more type of modules that can be used to transmit data using your Arduino. A SIM card, it's the one that can read your SIM tray cards for phones in case you want to send text messages. You can use this module with your Arduino and turn it into a smartphone. Or GPS modules, instead of you, in case you want to track your location, you can do that as well using UART. So how it works, instead of a synchronization clock, I forgot to mention it. It doesn't need a clock to synchronize. That's why it's asynchronous. It's asynchronous because instead of a clock, it uses something called a baud rate, which I'm going to discuss in the next slide. And since we receive and transmit data, we communicate. So how it works, instead of synchronization clock, devices they have the same baud rate. That tells you the number of bits per second that are transmitted. So for instance, the most common baud rate, it's 9,600 bits per second. That in time, it's equal to 104 microseconds. So that means that every bit will last 104 microseconds, and then it's going to move on to the next bit. Since we transmit a byte, which is 8 bits, we also need a start bit and a stop bit. So as you can see here, I'm transmitting these 8 bits, this byte, which is 10011010, and added to those 8 bits, I have one start bit that will go to 0 and a stop bit that will go to 1. When there's no communication, we are in level 1. Notice that every bit, as I mentioned it already, lasts 104 microseconds. So the start bit, which is your 0, it's 104 microseconds. Then we go to a 1, which is 104 microseconds. Then we have 2 zeros, and every 0 lasts 104 microseconds. So the baud rate will tell you the amount of bits that can be transmitted in a second. The higher the baud rate, the fastest the data transmission. Even though the most common baud rate is 9,600, based on my experience, I've seen devices that can go up to 3 million bits per second, which is a lot. And notice in my figure that the way to connect devices for UART communication are for transmitter to receiver. TX goes connected to RX, and RX goes connected to TX. Do not ever connect TX to TX or RX to RX, because if you do that, they won't be able to communicate. How do we code it? Well, we have 3 basic instructions. There's a lot more instructions that you can find in the UART documentation or the serial documentation from Arduino. Since I am trying to keep things simple for you, I'm gonna cover only these 3 lines of instructions. If you see in my picture on the right, your TX and your RX in your Arduino are pins 1 and 0. Keep in mind that when you try to connect one module, so let's say you want to connect your Bluetooth module, if you connect your TX and your RX to 1 and 0, you won't be able to see the data in your computer because those pins are connected to your computer already. There's a way, and we're gonna see that in the examples, to see the data in your computer, but if you connect a module, now you won't be able to see that data in your computer. In the same way, you need to use those 2 pins to program your Arduino. So if you have anything connected to TX and RX and you try to program it, you won't be able to do it. You're gonna see more about it in the examples. So let's go to the instructions. The first one, serial begin. So the only thing with this one, we need to write it in the setup function. The baud rate specifies the number of bits per second that are going to be transmitted. Keep in mind that both devices need to have the same baud rate. Don't mix baud rates. If your device that you're trying to communicate with uses a 9,600 baud rate, Don't write something else because you won't be able to communicate. The next instruction is println. Print, it's used to send data from your Arduino to your device or your computer or whatever thing you have connected. You can see here the string, which is in double quotes. Every letter, including your space here, it's represented by a binary code. That's what I mean when I say an ASCII. So W in ASCII represents this number in binary. Our ASCII is this series of numbers that represent that letter. So that's ASCII code, and that's how it works. When we write print, that data will be sent to the device. So print, it's going from TX from the Arduino to the RX of the device. And when we write serial read, we're listening data from the device. So now, from the TX of the device, the data has been transmitted to the RX. And this function is returning whatever we're reading or we're listening from the device. And that's how UART works.